Good morning, everyone. Welcome to Anitian's presentation here this morning on PCI compliance in Amazon Web Services. So what we're here to talk about today is an overview of some strategies on how one can achieve PCI compliance of an environment hosted in Amazon Web Services. We're going to do that by talking about how AWS supports PCI compliance for customers hosting within their infrastructure and the AWS services that Amazon makes available to their customers that can help meet some of the PCI requirements. We're going to talk about some PCI reference architectures that we have designed and built out for common use cases within AWS hosting, as well as the AWS services that support compliance, some of the third-party solutions available to augment the necessary PCI requirements, as well as general best practices and Q&A. This whole presentation is a high-level overview of a detailed workbook that Amazon just this month published that Anitian authored, which expands on all of the concepts we're going to go over today in great detail. We'll provide you a link to that workbook at the end of the presentation as well. So allow me, please, a brief introduction of the two of us presenting today. This is Adam Gaydosh speaking. I'm a Director of Professional Services here at Anitian. I'm also a PCI Qualified Security Assessor for the past 7 years, having done a wide range of PCI assessments, both the service provider and merchant side, with over 15 years of experience in IT and security specifically. Also presenting with me today is Jordan Wiseman. He's one of our cloud security specialists here at Anitian, a certified risk assessor, and he also has over 15 years experience in IT and security. And Jordan and I were the two lead authors on the workbook that Amazon published for us just earlier this month. So a brief overview of Anitian. Our real goal here is encapsulated in our mission statement, which is we enlighten, protect, and empower great security leaders. And it's based on our vision that we really believe security will make the world a better place. That's ultimately our end goal as a firm. And so we use our services as a means to achieve that, to help build great security leaders and truly make the world a better place. We recognize that for true innovation and growth, security is really necessary to empower that type of realization. And we try to take a very practical and pragmatic approach to all of our security analysis. And I would say that it's really the risk-based approach that is pervasive throughout all of our various service offerings that we use to try to ground our analysis and recommendations in that which is most applicable to the business. So we'll start with a brief overview of PCI in AWS and how AWS could support PCI and what some of the responsibilities are here. So the first thing, the big question that we hear still quite often is, can you be PCI compliant in AWS? Is AWS compliant? The answer is yes. AWS is validated annually as a compliant PCI service provider. They're level 1, which is the highest volume. They receive an annual validation, and that means that merchants trying to achieve PCI compliance using AWS as a service provider could leverage the compliance documentation that AWS has for their environment. So the main components of that documentation are the attestation of compliance, which is the proof that they are compliant for their annual period. And then more importantly, perhaps, is the responsibility matrix. This is an explicitly new requirement starting in PCI 3.0, where the QSA must delineate for every requirement that a service provider is compliant with, which of those requirements are fully met by the service provider or might have a shared or entire responsibility for the merchant that's using that service. And we'll talk a little bit more about that shared responsibility model here in a second, but the responsibility matrix is the key delineation of how that works. But the bottom line is AWS is a PCI compliant service provider, but that does not mean that that compliance is inherited to customers hosting in AWS. They do still have a responsibility for achieving compliance of their own. So this is a brief overview of the demarcation between the customer and Amazon concerning PCI responsibility. The simplest way to think about it is the difference between security of the cloud versus security in the cloud. Security of the cloud is what is validated by Amazon's AWS assessment as a service provider. Security in the cloud is the responsibility of the customer to make sure any of the resources that they are deploying within the compliant AWS cloud are configured and managed to meet the PCI requirements. So at its simplest level, that's the real difference. Of the cloud is the underlying infrastructure of AWS, starting at the physical locations on the very bottom of the diagram, and then the next row there in orange, which is really the technical infrastructure backbone of AWS. And then the blue stack is all of the layers in the customer environment that they are deploying on top of the cloud. And so it's those assets that the customer is deploying within the compliant cloud that they are responsible for configuring to make sure they're compliant. For simplest example, you spool up a virtual machine in AWS. That machine, it's your responsibility to make sure you've hardened it, you've patched it, you've got AV, you're doing log management, and all the other requirements. The infrastructure it's running on, which is managed by AWS, that is validated by the AWS audit as a compliant service provider. So the next thing I'd like to do is talk a little bit about the different services that AWS offers within AWS that can be leveraged to achieve compliance with the various PCI requirements. This is, again, a high-level overview. Jordan's going to expand on some of the technical details supporting these various services. However, again, keep in mind there's quite a bit more detail in our workbook, which is published on the AWS website. We'll provide a link to. This is just an overview, but we're going to talk a little bit about some of these services here, starting with requirement 1. So requirement 1 is installing and maintaining a firewall configuration to protect cardholder data. So this is basically your network, your segmentation, ACLs. So Jordan, if you could please talk a little bit about some of these services and how they support those requirements.
Sure. Within AWS, customers have the ability to control networking, subnetting, segmentation, and routing between the networks within their AWS account. This is accomplished primarily through the use of virtual private clouds. Security groups are more of a firewall than purely networking piece, as well as the ability to leverage access control lists that you can apply to network traffic coming in and out of the virtual private clouds, or the VPCs, within an AWS account. Each VPC has its own supernet network that's separate from every other VPC, and stuff within one VPC, so instances that you launch, other aspects and resources like databases and storage that you take advantage of within your account are self-contained within each of the VPCs. The one point worth noting between the two of them is that security groups, when you're talking about firewalling, are in fact stateful. They track related connections. They make sure that only traffic associated with an internally originated connection are allowed. Network ACLs are not stateful, which is a specific PCI requirement, as I understand. They can be used to help segment traffic, but because they're not stateful, they alone don't specifically just meet that PCI requirement.
No, not for the primary segmentation technology. So one of the ways when we talk about virtual private clouds, we'll try to map some of these concepts which are abstracted in the cloud space back to some of the more traditional network technologies. And when I think of virtual private clouds, really I think of those as fully standalone networks.
Yeah, they're a lot like within your organization, when you talk about segmenting networks and traffic, you stand up a separate subnet, you control traffic between them. Well, a VPC takes that a step farther in that it's as if those networks are air-gapped.
Correct.
When you first create one, there's no connectivity between them, even between them and the rest of the world. They don't have internet access by default, for example. You can take steps to provide that kind of access, but as it is, they're self-contained, isolated networks within your AWS account.
And we'll talk about this more in the reference architectures, but in most cases, you're implementing the segmentation within your individual VPC. However, you absolutely could have multiple VPCs, which are fully isolated, unless, of course, you route between them, which is, we'll touch on lightly here, but is a little bit more of an advanced concept.
Additionally, getting into the other strategies and considerations here, so security groups and network ACLs are firewalling technologies built into AWS.
That's right.
VPCs as being completely isolated and not having traffic by default routable between them is also one way of achieving segmentation. Something else you can do is there's a lot of third-party vendors in AWS Marketplace that supply third-party Amazon machine images. That's AMIs is Amazon's term for what their templates and their base starting points are.
A virtual machine, effectively.
Yeah, basically. Third parties that provide firewalls, unified threat management and gateways, as well as IDS and the IPS systems that you're used to with your traditional firewalling. And in fact, most of those AMIs come from your traditional vendors, your FortiGates, your SonicWalls, your Palo Altos, the people that you're already used to, the technologies you're already familiar with. Those are available within AWS for use as your firewalls if you want.
That's right, virtual machines that you could spool up and deploy as a virtual firewall or IPS. Now we're going to talk about this throughout some of these services, ways you could augment the native AWS services with third-party AMIs there. There's an AWS marketplace where you can purchase all of these. You spool them up. In most cases, it's a bring your own license model where you would download the Fortinet or Palo Alto image, spool it up, and then you have to enter the license to actually get it running. Okay. So the next requirement here is requirement 2, which is effectively the host hardening requirement. So this is one that is really wholly the responsibility of the customer. Any of the images that you spool up as a system in your VPC, it's your responsibility to harden that. Requirement 2 is the hardening requirement.
Right. So like we talked about third-party AMIs that are available for different technologies, you can actually create your own. So you can set up an instance, you can get everything configured and secured the way that you need it for your PCI environment, and then you can turn it into a template that you can base other instances off of. That saves you time in hardening, configuring, and allows you to demonstrate, look, this one's configured, this is the one I based everything off of, and that's something you can hand to your QSA as evidence.
Very similar to basic templates in VMware, for example, if you're familiar with that technology. You build out your template, you harden it, you lock it down to whatever your internal standards are, and then you spool up instances from there. You could do the same thing in AWS.
And the other considerations, there's really 2 primary considerations when you're talking about host hardening, especially when it comes to default passwords. So no Amazon supplied AMI has a default account or password set. They're generated randomly every time you launch that instance. This may not be true of third-party stuff. So if you do go get a third-party AMI from the marketplace, it might have default configuration and accounts that you're going to have to change. And that's something that you need to make sure that you follow up on and document as part of your process.
And Anitian has actually built pre-hardened AMIs that are available in the AWS marketplace. They're specifically hardened to the guidelines in PCI. So you can go into the marketplace and spool up these instances. We also include a documented host hardening procedure, which documents everything that we hardened to those instances for the different distributions that are available for Linux. And Windows is also coming soon as well. So there are some other options if you don't want to do it yourself. So the next requirement here is data at rest. This is your encrypted cardholder data, your classic e-com with a back-end database that stores credit card numbers for one-click shopping, for example. How do you secure that data? That's what we're going to talk about now.
So all of the primary storage technologies within AWS, so the Elastic Block Store, that simple storage service that everybody is familiar with, as well as their hosted database service, all support encryption by default. You can leverage the Amazon key management service for private key generation. You can supply your own keys in certain instances, and you can allow the system, especially where S3 is concerned, to manage its own encryption keys. But the point is you can turn on industry standard strong encryption. By default, they use AES 256 for symmetric encryption and to encrypt the storage for your VMs. So a couple things to note. Elastic block storage, which is the typical storage used for most instances running within an AWS account, the root volume cannot be encrypted. So when you spool up a new instance or launch a new instance, the volume that the operating system itself sits on can't be encrypted. You can create secondary volumes that are encrypted and attach them to the instance. That being said, PCI, as I understand it, Adam, requires that access to encrypted data be independent of operating system. In other words, it can't be transparent to any user that logs onto the machine.
That's absolutely correct.
Okay, so that's one shortcoming of EBS, specifically that if you create an encrypted volume and attach it to an instance, anybody that can log into the instance is going to be able to access that volume. It works just like hardware-based full disk encryption that you would have in a regular server. So if you're going to do that, that's great. It's an extra layer, but you're going to have to use an additional file or volume level encryption on top of that to meet the PCI requirement. Additionally, if you manage your own databases, if you have your own SQL or Oracle install in an instance, you're going to have to leverage something like transparent data encryption because you can't rely just on the EBS volume encryption for that, and it's not separate from the RDS instances as if you were using the Amazon one. If you rely on RDS, Amazon's hosted database platform, to actually provide that platform, you can use volume encryption there because it's independent from your instances. Your instances are accessing the database itself as a service, and nobody that logs into your instance has direct access to the volume of the data files or any of it. So that will let you do what you need to do.
That's right. So RDS is the database as a service, which is different than if you self-manage the DB by spooling up the underlying operating system to host the DB, installing your own DB server on top of that, and then managing it natively like you would in any other environment. And then S3 and EBS are the other two storage technologies available. KMS is a management service that could be used to manage encryption keys for any of those three technologies. Okay, let's move on here, because we've got a lot to talk about today in a limited amount of time. Again, more detail in the workbook, so if it seems a little light, it's a dense topic and we want to keep it digestible. So requirement 4 is encrypting transmission of cardholder data across open public networks. This is, for example, the big 3.1 change of no longer allowing SSL and older versions of TLS as a secure transit encryption technology. So AWS offers quite a bit of services that can support components of this.
Right. So most of these services that AWS provides that can help ensure transport level encryption are really more about restricting access to those ports, protocols, and technologies that are encrypted. In other words, using network ACLs and security groups to ensure that incoming connections to web server are only, over, HTTPS over TCP 443, for example. The customer gateways, virtual private gateways, and VPNs allow you to establish a traditional business-to-business VPN connection between, one network and another within AWS. It works just like it would at your site, and you can ensure that there's IPsec in place and that the actual transmission of that traffic is encrypted using industry-accepted best practices for cipher suites and key lengths and so on. Direct Connect is a private network connection, which isn't necessarily encrypted, but so you might have to use additional encryption there. It's a lot like MPLS, redundant networks that a lot of people use. That's
right. Private MPLS is how I think of it as an instantiation of that.
Right. Elastic load balancers is a little bit an additional level of security here, and we'll talk about it a little bit later, but one of the nice things about using Elastic Load Balancer is you can use it like a security group to ensure that incoming connections are really only on a single port, but you can also use it to abstract the actual backend boxes that things are connected to. So we'll touch on that later. That's not related to encryption, but they're a really handy technology for a couple of different things within AWS.
Sure, and the other things to keep in mind, obviously, if you're spooling up your own web servers to configure the ciphers you're using to be robust at the system level. That's your responsibility within Apache or IIS, for example. Any VPNs that you might deploy as perhaps part of a third-party virtual firewall that might support VPNing. Of course, you have to configure that way to be secure, just like you would in any other deployment.
Well, and on that topic real quick, the last bullet point about standards for encryption strength, what's commonly accepted as strong cryptography changes as the capability of computers gets stronger and stronger. Just like on-premise, how you may have to go revisit the cipher suites and the key lengths that you're using for your own web servers, you need to do that within AWS also. The web server instances that you spin up and launch in AWS are just like the ones on-premise, and you need to track those things accordingly.
Yeah, that's a good side note while we go to the next requirement here, that really it's a reminder that people oftentimes misconstrue that a PCI assessment is the validation of compliance and means they're compliant. It is a validation of compliance at a point of time, but to be PCI compliant is a continuous state of either compliance or not. So to Jordan's point about making sure you're monitoring the industry developments to ensure that if the standard says you must use robust and secure protocols, that may change. So it's always the responsibility to be maintaining your environment, not just during the annual assessment.
Which is a great segue into the next topic here. Requirement 5, Adam, if you want to.
Is antivirus, quite simply.
Well, so instances that you launch within your AWS account are your servers and operating systems to manage. AWS doesn't provide anti-malware services. Their VMs don't come with pre-built anti-malware, intrusion detection, all that kind of stuff on the instances themselves. You need to install, provide, and manage that software.
Mm-hmm. And you might make a determination that one of the systems you're using is not commonly affected by malware. There is that phrase in requirement 5. You need to take a risk-based approach to justify if that is the case where you're ruling out a particular system not being commonly affected by malware, but you may make that determination. If you do, you need to continue to monitor to make sure that assertion has not changed. For example, Amazon has their own Linux distribution called Amazon Linux. Perhaps you make that determination. It's not commonly affected by malware. Whether or not that's the case is really up to you justifying through risk assessment. But if you're able to do so now, that doesn't mean that is forever. You always need to evaluate that. And just, in most cases, though, you're going to be meeting this requirement using some other type of antivirus solution through a third-party AMI if you're splitting up a management console within AWS.
Well, just like we mentioned with the firewalls, the third-party, all of the usual suspects offer AMIs in the marketplace for anti-malware solutions. So Trends out there, Sophos is out there, McAfee's out there. They've all got AMIs that you can use. You can launch within your account. You can use it in your account to manage your AWS resources locally. And as we'll talk about later, you can also extend your on-premise solutions for managing the PCI resources you have in AWS, just like you manage your in-scope and your CDE systems on site.
That's right, using something like Direct Connect or some type of point-to-point VPN to route traffic from a network on-prem that has some of the security consoles that you need, such as a AV management console, back to your VPC. Segmentation concerns, of course, need to be met, but otherwise, yes, you can do that. Okay, so requirement 6, this one here is a bit of a bucket requirement. This touches on patch management, of which AWS does not provide anything explicitly. And then it also includes the change management and secure software development requirements. Again, none of these things are directly provided by AWS.
Well, and none of them really directly apply to cloud infrastructure services really. These are about business and technology process kind of things. Really.
Exactly.
Amazon does publish what they call the Amazon Linux AMI security bulletins, which there's a URL to them right there. Anytime updates are released to their system for security reasons, just like the notices you get from the Red Hat bulletins and Microsoft security notices, all the same kind of thing, Amazon publishes them for its own Linux distribution that it deploys as AMIs. Amazon also has a couple of services you can leverage within your own efforts if you'd like to. We won't get into them in detail because they're a little out of scope, but Code Commit and Code Deploy are managed Git repositories and package management that are hosted within the AWS cloud. And of course, there's, again, third-party AMIs from all of the usual suspects for doing change management and change control of your systems.
Yeah, the bottom line is to meet this requirement for patch management, you've got to do that on your own for all of your systems, be it having some type of management console deployed in your VPC or back on-prem or direct out to the vendors. And of course, configuration management, again, there's some services that might help with some components, but by and large, you're going to need your own way to track changes and of course, document the secure SDLC if you have an application in scope.
One important point real quick that occurs to me, one common question that we get, especially from auditors, has to do with those Linux supplied AMIs, so the Amazon Linux instances, right? Amazon Linux is just like deploying Red Hat or SUSE or any other distributions. Once it's installed, you have to manage the packages. Just because it comes from Amazon doesn't mean that the updates related to their security bulletins are automatically applied.
Oh, that's right. The hardened images that we provide within the documented host hardening procedure, step one is spool up the instance and update the patches.
Right. Now, some of the tech guys, that's kind of obvious, but it's a question that we see a lot from auditors. So something to keep in mind when you're going through your own assessments.
Okay, requirement 7 and 8 there's enough overlap, certainly at the AWS level, that we're grouping these together. This really concerns, requirement 7 and 8 deal with account, user rights, and account management
Identifying who did what to which systems when, right?
That's right. What access do you have and what are the requirements around use of your account, password complexity, those types of things.
So AWS offers identity and access management as a service, as well as the ability to spin up or to launch directory service instances. So hosted Active Directory.
Active Directory compatible.
Well, actually,
yes.
Active Directory compatible.
But effectively, it's an Active Directory as a service,
right,
versus having to spool up your own Windows server and run your own Active Directory on a dedicated server instance, which you can do as well.
Right. Now, IAM is specifically used to control access to AWS resources. You've got a lot of flexibility and granularity available to you in access control, but it's important to note that controls who can do what within AWS, not necessarily the environment that you build on AWS. Your instances and their operating systems and necessary management are going to be separate from IAM.
It's a hugely important distinction to understand when you're preparing for your assessment. IAM is what you're using to provision access effectively to the AWS management console. So think of your sysadmins, they're actually building this environment out. Once they build out the environment and spool up a web server and a database server or whatever you need in there, as Jordan was saying, the accounts that those systems are actually using, those are not managed through IAM. Those need to be managed through directory service or another alternate strategy such as hosting your own directory server either within the cloud or on-prem so that you can manage all of those accounts at the granular level required by requirements 7 and 8.
It is worth noting that you can connect IAM to the directory service or to your own hosted on-premise thing if you want to centralize access management that way. But by default, and even if you do that, that's only about authenticating users. It doesn't, authorization, the actual access controls are still specific to what people can do within AWS itself.
And there are some limitations to IAM to the specific requirements in requirement 8 in any case. So. Right. Requirement 9 is physical security, and that is not applicable to people hosting there. When we talk about the underlying infrastructure is covered by the AWS service provider assessment, the most glaring example is physical security of the data centers. I mean, they don't even publish the physical location of these data centers, let alone give you some type of responsibility requirement to validate that they have the appropriate controls. So that's just totally off the plate for your responsibility. Requirement 10, however, is the responsibility of people hosting there, and there's quite a bit here that needs to be addressed, but at the end of the day, this is the log management requirement.
So the important thing to note here is a lot like IAM, these services have to do with accounting for who's accessing, changing, controlling resources within AWS. So natively, AWS supports or offers a service called CloudTrail, which tracks all actions that anybody takes or can track all actions that anybody takes within an AWS account. It actually uses an S3 bucket to store all that data. So the same management that you would use for the bucket, including lifecycle management, encryption, access controls, control who can get to those audit records.
So CloudTrail is the head end for managing the logs, and S3 is the back end data storage.
Right. CloudTrail also offers an API, like most AWS services, in fact, offer an accessible API that you can use to actually pull that data into your existing security management solution if you've got one, or if you're going to host one in the cloud there too. You can use that to provide real-time monitoring or automated monitoring and collection of those logs if you want to. CloudTrail logs all actions taken within the AWS console itself or done programmatically via the API, which includes the command line access. So effectively, that's everything that anybody does within AWS itself. It doesn't include, again, what happens within your instances. So you still have to have log management and access tracking and security logging within your launched instances.
So just to clarify that point, what we're saying there is if one of your admins that has access to your management console within AWS spools up a new instance of a server, that action will be logged within CloudTrail.
Right.
However, if he then logs in to that server with an account and then sudos and makes some changes and does some other things within that server, that is not necessarily logged to CloudTrail unless that server has been configured to dump logs.
Right.
So that's the important difference there.
So another important note is that AWS does not include a native time synchronization even among the instances. There isn't a native NTP system. So it's a best practice to set one up or point all of your hosts at least a common time source.
This is the service we're talking about. You're required to have internal master NTP servers that talk out to authorized external sources. And the bottom line is AWS does not have an NTP service. So you'll have to configure one and have all of the systems in your VPC communicate to the service that you configure. And of course, the point of that is to ensure that you have consistent timestamps across your logs in the event you have to do some type of incident response. Obviously, you need consistency on timestamps. Okay, requirement 11 here. This is the security testing requirement. So this covers a range of things such as rogue wireless access point detection of physical locations, which of course is not your responsibility. It's covered by Amazon, their service provider validation. It also includes vulnerability scanning, penetration testing, intrusion prevention, and file integrity monitoring. So there's some testing requirements, and there's also a few detection requirements. And so we'll talk about those a little bit here.
Well, it's really just important to note there's no specific AWS services that address this. Because of their existing attestation of compliance, they test their systems annually. You have to test your own systems annually. So the instances you manage within AWS is just like your on-premise PCI stuff. You need to do all of your typical security testing, so penetration testing, vulnerability scanning, and so on.
There's no service provided by AWS to perform those. And so, yes, you have to do it. Of course, the pen testing and vuln scanning of the underlying infrastructure is covered by their assessment, but not of whatever you spool up. Also, when we talked about this before in requirement 1 with firewalling, we mentioned third-party solutions such as UTMs, Unified Threat Management appliances, which is basically a firewall with additional network security services such as Fortinets and Palo Altos. And the reason we mention that is while the native services in AWS can provide the firewall policy access control list requirements for segmentation, they don't include intrusion prevention or detection. So you will need to spool up something there, probably from the marketplace, be it a dedicated IPS or a firewall that includes that to provide the IPS. And then the last piece, 11.5, is file integrity monitoring, which occurs, of course, at the system level. You need to configure something for that to do the file change detection. You're fully on your own there.
Yeah, and just like we mentioned with the third parties, that applies to here too. There's AMIs in the marketplace. I mean, Qualys has them out there, Tripwire's out there. All the usual suspects are there too. So the stuff you're already familiar working with is available to use within AWS.
So the last pieces here are pretty simple. Requirement 12 is basically the policy requirements, and Amazon is not rating your policies for you, quite simply. So of course you're on the hook there.
That would be handy, wouldn't
it? That would be nice. However, we wrote your host hardening procedure for you if you choose to use our hardened AMIs. So we can at least help you with that piece. But nevertheless, it's only a small sliver of all the documentation that's required. The last piece is shared hosting providers must protect the cardholder data environment. And so if you are using AWS to be a shared hosting provider, if you're providing some type of software as a service
or third-party billing system, something like that.
Yeah, that is multi-tenant in AWS, you can certainly do that, in which case you would have to be assessed as a compliant service provider for whatever merchants are using your service in AWS, and you need to make sure that you were implementing the appropriate segmentation between the various tenants that are using your service, just like AWS has to do. So it's Amazon's responsibility as a service provider to make sure those VPCs are truly separate so that people can't access each other's environments. You have to do that within your environment if you're a shared hosting provider, but it's using the same technologies we already talked about for segmentation, account and access management.
So we put requirements 1, 7, and 8. They really have to go through all of them. But so Adam, if you were going to go and assess somebody, wouldn't somebody who wants to be a shared hosting provider and leveraging AWS for that also have to create their own responsibility matrix, just like Amazon did?
That's right. As part of their assessment as a service provider, that would be created as well. And that would delineate what within their environment. So if they're providing software as a service for something to do with, let's say, IVR, interactive voice recorders, which are commonly used for online phone-based payment systems in an automated fashion, there's nothing stopping one of those vendors from spooling up an IVR as a service in AWS. They then need to be assessed as a compliant service provider with the responsibility matrix, et cetera.
Okay.
So with the remaining 10 minutes or so that we have before we get into the Q&A, we're going to go over some of these reference architectures that we have built out and talked about in obviously greater detail within the workbook, but we're going to touch on them here. Again, these are common use cases for how you might leverage AWS to host a PCI compliant environment. So the first one that we have here is what we call the dedicated environment. So
this is an entire AWS account basically that is your CDE. It's the example here is a web store front end, right? You've got a web server in a DMZ that's accessible across the internet for selling whatever the product is. It accepts payments, it accepts customer information and all that. You have a jump box also in the DMZ. This is your management appliance. We could create some additional segmentation to pull that out of the CDE itself, but it would still be in scope for assessment, so it really doesn't make a lot of sense here. In addition to that, you have a back-end isolated subnet that includes the actual application and business logic servers that actually process the information, as well as the database that stores everything.
And these are, of course, simplified examples. You could obviously add more complexity, make it a true 3-tier with multiple subnets to keep your app tier instance separate from the Amazon RDS service that you're using for storage. We use the Amazon RDS service here in this example because, frankly, we recommend it. Anitian does that ourselves for our own deployment because there's no need to spend the time and money to manage your own dedicated database instance if the Amazon service that's available can meet all of your business needs and cost less from a utilization charging perspective.
Exactly, and RDS is fault tolerant and redundant out of the box, including with geographically dispersed physical location. I mean, it's everything you want your regular SQL DBAs to do without having to take the time to do it. Your DBAs would probably appreciate it.
And that's really the whole point of using a cloud service in the first place, is you want to leverage as much of their infrastructure as possible to minimize your responsibilities. So anytime you could use a native Amazon service rather than spooling up your own instance to accomplish that, we recommend you do so. You just need to be mindful of the any contingencies that might apply to meeting a given requirement.
So quick notes, details on the environment. Since the entire AWS environment is dedicated to that e-commerce application, the whole thing is in scope. The primary features from a segmentation management aspect here is there's a DMZ subnet for the instances that can contact the internet. There's an internal subnet for the instances that shouldn't contact the internet, that host the application and data itself.
That's right. And since there would be cardholder data in both of the two subnets in this model, they would both be CDE networks. The front end web server where you're posting the payment card if as e-com, which then hands that off to the app tier and then ultimately stored in the database tier in the second internal subnet.
Right.
So now let's talk about the second architecture that we have here. And this is the segmented, to differentiate what we just talked about, where the entire VPC, your whole AWS environment, was in scope. Here we have two VPCs. Building on the last architecture, and the third one follows this model as well, where we're just expanding out on the initial architecture. So the primary VPC on the right, which is the CDE VPC, that's the same as architecture 1. We've now just added this out-of-scope VPC.
Right, so you start with this environment, now you realize that, wow, AWS is really, really cool. Let's host some other stuff up there. So you can create an additional virtual private cloud within your account that there's no direct connectivity. You'll notice that the internet gateway is the actual point of access to those virtual private clouds are separate from the two VPCs. So your cardholder data environment is entirely contained within its own segmented network and space within AWS, and you've set up an entirely separate, independent, logically air-gapped system for your non-PCI related systems, all within AWS.
And without adding complexity, as we talked about earlier on with VPCs, yes, you could route between these if you wanted to, but then you would have to have concerns with policies to make sure you're not bringing things into scope you don't want. In this model, since we want to just demonstrate, you could have a dedicated environment for your PCI environment in one VPC and another dedicated VPC for all your other enterprise resources that you want in the cloud, fully segregated so that your PCI assessment only applies to one of the VPCs, not the other.
So again, quick notes about this. Separate virtual private clouds for the PCI and non-PCI environments, effectively air gap them so there's network segmentation between them, and the PCI scope in this case is reduced from the entire AWS environment to just the PCI VPC and the instances it contains.
That's right. So our last architecture we're going to talk about here is what we call the connected architecture. And what we mean by this is we've got the two VPCs that we initially talked about already that are totally out of scope in our cardholder data environment. We're actually cranking this up a notch with two new factors here. We are adding a third VPC, which are systems which are in your assessment scope but not in your cardholder data environment. I'm going to talk about that briefly here from a QSA perspective because scoping is often misconstrued. And then the other new piece is that we have the on-prem environment that we are connecting into AWS, which really is a common use case. Let me just very briefly, because we don't have a lot of time, talk about this point. The assessment scope is the cardholder data environment, which are the networks that have systems that touch credit cards, payment cards, which is why it's PCI, of course, and then any systems connected to that cardholder data environment. So in the model we have here for the AWS zone within the account, we have three VPCs. The middle VPC, these are in-scope systems. The reason they're in scope is because they have a firewall policy that allows them via VPC pairing, to be specific. VPC pairing is letting the VPCs that have in-scope systems connect to the cardholder data environment VPCs to provide some service. Right. However, there's no cardholder data flowing between them. All cardholder data lives in the CDE VPC, but you might have other systems that need to connect in for any number of reasons, be it providing a security management service, be it
this
reporting.
Is where you put those antivirus instances we were talking about, the integrity monitoring.
That's right.
Any of those kind of management stuff. They don't handle the credit card data, but they touch the CDE, so they're in scope. You have that routed connection via the VPC peer. It's kind of like a router or bridge between the VPCs. I know there's a different networking technologies, but it logically provides a connection between them. They all still have their own internet connection as well.
And so let's briefly touch about how you can connect them to the on-prem.
Sure. So from within the CDE VCP, you can set up those aspects I mentioned before, the services I mentioned before, the customer private gateway, the virtual private gateway, and the VPN connection to actually create a typical business-to-business IPsec tunnel between the cardholder data environment in AWS and an on-scope network that's actually on-premise. It works just like a traditional business-to-business VPN connection, so isolating traffic that goes across it, you still have to put effective routes and policies and all the things in place to ensure that only appropriate traffic is going across that connection. But it's a really easy way to provide access between the CDE itself to your on-premise environment without necessarily providing direct internet access to all of the stuff contained within the cardholder data environment.
Yeah, the common use case we see here is organizations already have some of the security consoles like a AV management console or a log management console. And so they don't want to necessarily...
Or a directory service.
Or a directory service. They don't want to spool these up as dedicated within AWS. So they can host them on-prem and then route them through over a VPN connection or some of the other technologies to AWS. The important part to note is that it's the customer responsibility to enforce the network access control over whatever that point-to-point connection is to make sure that only the systems that you want to be in scope actually have that logical network access. So as we show here, the box on the upper left has systems on the LAN at the on-premise environment totally out of scope. That only occurs if the firewall policies are set up as such that there's no way they can route into AWS.
Right. And all of those AWS services we talked about for firewalling, security groups, network ACLs, and even the third-party firewall AMIs that you would or AMIs that you would launch to do firewalling, you can use those to control access in and out of the tunnel as well. So quick notes, things that we really just talked about here. The scope again is just the AWS CDE, the in-scope networks, both on-premise and in the environment itself.
All right, so we're briefly going to touch on some of the third-party solutions here that we would recommend you take a look at. We've talked about these throughout some of the requirements already, so we don't want to get too much into these at this point, particularly to be mindful of time.
They're all available within AWS Marketplace. As you can see there, these are screenshots from the marketplace itself. They're all the typical vendors, things and solutions you're already used to familiar with. Chances are if you've got a Palo Alto firewall on site, you can find a Palo Alto AMI that integrates with your existing system and you manage it the same way. And that's true for pretty much all of the other security vendors that you're used to on site. All of the big names have AMIs available.
So just search for Anitian, you'll find the AMIs and you can spool those up for the hardened instances.
So some of the third-party AMIs that you really should consider that are related specifically to PCI compliance will address gaps or things that aren't immediately natively available in AWS
Right.
services.
This is a summary of what we talked about. The key requirements not met natively.
Exactly. And some of them enhance existing AWS stuff, more capable firewalls or more easily manageable firewall, or not easily manageable, more fine-grained firewalls.
Yes.
As well as third-party VPNs if you need them, and even some solutions to help automate and document processes within AWI or AMI.
Yeah, that's right. So a few best practices here, specific to AWS, but also PCI in general. Something that we'd like people to consider when they're preparing for their validation assessment, be it a self-assessment or if they're getting a formal assessment by a QSA. What do you need to do to prepare? There's a few basic items that you need to perform here.
Right.
Tasks.
Reach out to whoever your rep is with AWS, or they have business contacts you can find on the AWS compliance site, which is aws.amazon.com/compliance. Request a copy of the compliance package. It includes that responsibility matrix we talked about. It includes their attestation of compliance. You will have to sign a non-disclosure agreement.
Right, not publicly available, but they are easily available if you're a client.
Right.
The other things you want to do is make sure that you have all your documentation in place to prepare for the assessment. And some of this could be performed within AWS itself.
Yeah, using the config service and trusted advisor are two services within AWS that provide detailed reviews and automated checks of your environment. Are you following best practices to secure your AWS account? Trusted advisor can tell you. Who changed what when and what's the current configuration of a given AWS resource? Config can tell you that. Some things to talk about related to AMIs. Every AMI has a unique identifier, so you can use that to track which ones were configured when. You can also use it to demonstrate which AMIs were based off of the one that, maybe you started from a secured one that you got from us in the marketplace. Maybe you started by securing your own, but that identifier allows you to show somebody exactly what that was. The AWS console has a lot of rich information that you can use for compliance purposes. Screenshotting current states of everything are right there. And really important too for reporting and tracking purposes, every resource within AWS can be tagged with an arbitrary tag. You give it a name, you give it a value. You can use that to easily identify all of your PCI related services within your AWS account really, really quickly. In fact, you can use a single tag to create a resource group out of all of it. Technical considerations related to compliance or related to managing AWS in general. For monitoring your system, leverage CloudWatch. You can create automated alerts based off performance metrics for your launched instances, so you can keep track of what's going on, and AWS can let you know when there's a problem, just like you monitor stuff on site. The first things first, I talk about naming conventions and especially encryption keys. When you're planning stuff in AWS, decide what you want to call it, decide what your names are going to be, because some of those things you can't change after the fact. Tags can be changed, names not necessarily.
That's right. We have quite a bit of detail in our workbook that talks about building out the reference architectures that we glossed over here this morning. And they include absolutely a recommended order of operations so that you can build these out and manage the environment in alignment with general best practices, not specific to PCI, but just ease of use and administration,
Right.
general system cleanliness. So that is expanded upon in great detail there, but it is important to be mindful of, to have some plan going into this.
Right. Create your keys before you need them, same kind of idea. And then for ELBs, I mentioned this a little bit before, elastic load balancers are handy not just for load balancing, not just for abstracting instances, but you can use it to provide seamless and automated fault tolerance for all of your aspects too. You can put an elastic load balancer between your application servers and the database instances, between your web servers and the application servers, between the internet and your web servers. I mean, at every point. Some folks have always sat down, you've got a big IP internally or you've got a NetScaler internally and you want to be able to apply it to everything. You just can't because it costs money. Well, ELBs are free. Use them for everything.
Okay, and so this is just a general overview of our recommendations for preparing for an audit. And this really applies, frankly, to almost any PCI assessment, not specifically to AWS in all cases. The biggest failure that I see across the board in any environment is hopefully there's some type of project manager, be it technical or not, that is responsible for the compliance readiness effort, assigning different technical tasks to various stakeholders. The DBA has to encrypt SQL and the Linux admins have to lock down Red Hat, etc. That's fantastic. The failure usually occurs to have some type of internal validation that all of those requirements were effectively implemented per the PCI standard. You don't want your auditor to be the first person who comes on site to see that did the DBA really understand what the PM asked him to do. So to do that internal readiness assessment, to go through and meet with those people to have them explain how they implemented whatever task was assigned and make sure that maps reasonably to the PCI standard is a really important step that is often overlooked. And it introduces a lot of audit stress when you're scrambling to fix all the little deltas and gaps. So I highly, highly recommend that you allocate the resources from a time and personnel perspective to perform that prior to your formal assessment. Documentation, it's a huge component of PCI. It got a lot bigger for 3.0 and 3.1 with all of the security operation procedures that are required. Don't overlook that. It's very important. Network diagrams and data flows, scope and inventory. It's extremely important that you have very clearly defined documentation of what your assessment environment is. It's explicitly stated in the DSS that it is the responsibility of the entity that is being assessed to prepare and document and define that. Of course, the QSA is going to review it and validate, and if you misunderstood how a scope needs to be defined and you implement it incorrectly, you're going to have problems. But you also need to document that. It starts with the data flows, understanding where the cardholder data lives, mapping it throughout your environment, implementing your segmentation, and then documenting what your final scope and inventory looks like from there. Make sure you have all your testing in place that's required, the penetration test on an annual basis or after any significant change, quarterly vulnerability scans, annual web application security testing. You've got to make sure all of those annual tasks are in place. Even if it's your first assessment, you need to have at least performed them once. You can't say, well, we have a policy that requires we do this moving forward. You have to have had at least one passing quarterly vuln scan, one pen test. You have to have performed your risk assessment. All of these things have to have been performed at least once, even for that first assessment.
And like you said, that's important for lots of other compliance efforts. How many times do we go, we do compliance, we do ready assessments or audits, and we see clients that, oh, we have a policy. Well, great. Have you done it?
Right, exactly. You need to do it. So, and the last thing, this is really important. This is something, the workbook had two primary motivations. One, we wanted to make it easier for our clients and the AWS customer base at large to be able to understand how to leverage AWS to deploy a PCI compliant environment. First and foremost, that was a major intent of the workbook. But a secondary intent is that we were attempting to educate the QSA community at large to really understand the AWS technologies, which again are abstracted by design from what the underlying technology is, and that in some cases makes it difficult for QSAs to understand how they can meet a given requirement. Particularly with the plethora of non-technical QSAs, they really struggle with mapping these abstracted technologies to a given PCI requirement to be able to make that determination of how it meets the intent of a requirement.
Well, it's to answer that question. Can you be PCI compliant in AWS? The answer is yes, yes you can.
And we see QSAs that struggle with understanding these technologies, and so they default deny, and that doesn't help anybody. And so that's really what we're trying to accomplish with the workbook. But at the end of the day, you need to make sure if you're hiring a QSA to perform your assessment of your AWS environment, that QSA clearly understands AWS and the underlying technologies. So that addresses today's presentation. We would like to open the floor up to any questions. So we'll start with one here. This question is concerning the scope of the AWS attestation of compliance. And the question is, can you use AWS services that were not included in an AWS assessment scope? This is actually a great question. We hear this a lot. The thing is, quite simply, yes, you can. And here is why. Amazon AWS is an exceedingly dynamic environment. That is the beauty of the cloud. It is constantly growing, expanding its feature set, its capabilities. That's what you're paying for, to have them build out this powerful platform that you can leverage. Just like we talked about the power of leveraging the RDS rather than spooling up your own database server. The whole cloud, the infrastructure as a service, is constantly growing. Since an annual PCI validation is a point in time on an annual basis, when they're having their assessment performed, they have to put a freeze on what services are going to be in the scope of that assessment, even though other services are under development, will get deployed before the next assessment. What does that mean? That does not mean you cannot use those services. Why? Because all of those services are running on the same underlying compliant infrastructure that is already validated. So, for example, key management service, it is now listed as a compliant service covered by this year's validation that was just recently issued for AWS. Last year, though, it was not in scope because it was a newer service. That doesn't mean you couldn't use KMS, because KMS was still running on the underlying infrastructure. What it does mean for a service that's not covered by the attestation is that it's your responsibility, if you're using that service, to make sure you're configuring and using that service in a manner that supports PCI. So you can't just assume that KMS is going to be able to manage the key encryption to an appropriate cipher and key length to meet the robust encryption requirement. You have to be able to demonstrate that you've configured KMS appropriately through the interface. So it's a common question. It's easily misconstrued, but just remember, all of the services are running on the underlying compliant infrastructure. If it's not covered, you can still use it. You're just responsible for maintaining it.
So we've got another question from somebody who must understand AWS a little bit here. And this is actually a question that we just discussed very recently, in fact. So security groups don't log connections, so you can't use them for PCI compliance. Well, it's true that CloudTrail won't include a log of who connected to the system when. It will contain a log of who changed the security group, what change they made, and when they made the change. But connection logging itself isn't necessarily a PCI requirement. You have to have security monitoring and log management, but you don't have to actually keep track of every individual connection between some random person on the internet and your e-commerce website.
So one more question here. This perhaps is going to be the last one as we're about out of time, but it's a brief question. This also concerns assessment scope for AWS's assessment, and that is, are all locations and regions available within AWS PCI compliant? And the answer right now is no. They're not all compliant. They're listed in the workbook, the ones that are covered or not, and they're also, of course, in the AOC and the responsibility matrix that you could request from AWS. But the bottom line is, when you're configuring within AWS, you can select what regions you want to use to spool up your VPC and your various instances there, and you need to be sure that you're only using the regions that are covered by AWS's attestation. Because remember, when we're talking about the regional level, we're now getting down to some of these physical security controls and other things that apply at the data center level without speaking about why that might be the case. You just need to be mindful of the fact that you're only using those compliant regions. So that's all the time we have today. If anyone has any additional questions, please don't hesitate to reach out to us. Here are our email addresses, here, our website, our blog. The slides will be available. You can call us. The website and blog both have links to the workbook. You can get it on the AWS /compliance
Their security blog.
and /security. They have a blog where the director of security posted it just earlier in July. We really appreciate everyone spending their morning here with us going over some of the complexities of AWS. We hope we illuminated some of the ways that it could help you leverage their infrastructure to achieve PCI compliance, and we thank you for attending.